Cloud. Hi, I'm Matt Burns from the University of Missouri, and I'm really excited to have another conversation about research today. And today joining us is Sarah Cox, who is an assistant professor of special education at Eastern Michigan University. Hi, Sarah.
Hi, Matt. Thank you so much for having me today.
Thank you so much. She's got a really cool article that just came out. It's online. I'm going to share it real quickly so you can see it. It's about development of mathematical practices through word problem solving instruction for kids with autism. This one's a very special ed oriented one, kids with autism, although I'm willing to bet there are things we can learn from this for other kids as well, but this one's focused on kids with autism. The article is available online, so if you search it, you can find it. If not, I'm sure if you emailed Dr. Cox, she would happily send it to you. So that'd be great. I'm gonna stop sharing. So Sarah, let's start by first telling us about what did you study? What was the intervention?
Absolutely. So we used schema-based instruction in order to help students with ASD solve word problems. It was a slightly modified version of schema-based instruction. So in traditional schema-based instruction, of course, we are teaching students to identify the structure of the problem. So unlike keyword, of course, we aren't teaching them to identify specific words, but instead we're really teaching them to identify what's the structure of the problem, what's happening within that word problem, and then mapping that information onto a schema. So whereas in traditional schema-based instruction, you might teach them to draw the schemas themselves, we gave them schemas so that they could choose between them. So they didn't have to draw it because many of the students that we were working with had fine motor difficulties. So we reduced that barrier for them by giving them some different schemas. And then we also gave them a problem-solving heuristic. So whereas in traditional schema-based instruction, you might use some kind of mnemonic device like runs, we gave them a specific heuristic that was more of a step-by-step process. Again, the students that we were working with tended to rush through the problems rather than really taking their time. And so we implemented that heuristic, hoping that it would really help them slow down and solve the problem. And again, would reduce any potential language barriers that a mnemonic might introduce.
That sounds great. And tell us a little bit about the study. What method did you use?
Absolutely. So we used a single case multiple probe across participants design. We tweaked it a little bit. So we taught them two different types of multiplicative word problems. These were middle school students, 6th grade students. They did have autism spectrum disorder. They were receiving services under the autism umbrella in special education, but all of them were enrolled in general education math classes. And they had been identified by their teachers as having a difficult time with word problems specifically. So we first had the baseline where all of them had access to the material. So they had the heuristic, they had the schemas. We talked to them about what math practices were and the importance of communicating their reasoning and showing all of their work, but we hadn't gone through the schema instruction yet. So they had access to the materials and they knew what we were asking them to do, but we hadn't taught them how to do that yet. So in baseline, what we saw was most of the students were just trying to solve it, and most of them were answering incorrectly. One of them was answering inconsistently. So sometimes he would happen to get the correct answer, but he couldn't really explain how or why and didn't know the difference between when he had it correct and when he had it incorrect. And then we taught them the first type of problem. So we taught them how to solve multiplicative comparison problems, which is, the introductory multiplication problem. So you have something, you have your original set, it's being scaled, and then you have the new value. And what we found was that once we taught them to do that kind of word problem, they improved in their use of math practices. So they were able to reason, they were able to diagram that problem, they were able to write an equation to represent what was happening mathematically. They were, at the end, they were talking about what they did and why they did it and whether it made sense or not. We saw one student in particular that he would get to the end, he was explaining what he had done and he would catch himself and he would say, oh, that doesn't make sense. And he would have to go back and change it. And he would actually go back and change it, which is something that his teacher was saying that he wasn't willing to do during class. So we taught them that first problem, and then we probed them again. So again, they had access to the materials, but we hadn't taught them the second problem yet. And what we saw was 3 out of the 4 students started to generalize some of those math practices to the untaught problem. So again, they were starting to reason, they were starting to try and interpret what it might look like in proportion problems. And so we saw some of them make improvements, even though we hadn't taught that second kind of problem. So they were generalizing. And then some of the others were not as successful with that. So then we taught the proportion problems, and all of them again improved in their use of mathematical practices for those proportion problems. And then we went back to the probe where we gave them both types of problems, and we wanted to see what would happen. Would they discriminate? So in past studies, when we worked with students with autism, they often have a hard time discriminating. They solve the word problem however you just taught them to solve the word problem. So if the last word problem we taught was proportion problems, we often see students not discriminating between multiplicative comparison and proportion, or whatever the 2 word problems are. And so we have to go into a discrimination training where we teach them the difference between the 2. But in this study, what we found was 3 out of the 4 students were discriminating on their own. We did not have to explicitly teach them the difference between the 2 word problems. They were able to read the problem themselves and identify the structure and use their math practices to solve the problem successfully. The third student was slightly less successful. So we had set the mastery criteria that they needed to maintain the increasing trend, and he did not meet that mastery criteria. So he did need that discrimination training, but after 3 sessions, he also mastered discriminating between the 2 problem types and was able to successfully use his math practices to solve those problems as well.
But so this is so interesting, because humans don't generalize well, period, right?
True.
And children with autism oftentimes struggle with that. And so they're generalizing and discriminating. Did you add any kind of, did you build anything in to enhance generalization other than just the modified schema-based instruction?
We didn't. So the one thing we did do at the beginning was we talked to them about the fact that there were going to be multiple kinds of word problems, and that they needed to solve the word problems however it made sense to solve those word problems, which is something we were not very explicit about in previous studies. And so one of the last studies I had done, one of the students that I worked with said to me, I thought I had to solve it that way. And which made me think, about the instructions that we were giving, and were we explicit in the sense that they had that freedom to solve it however they thought it needed to be solved. So that was really the only thing we did, other than modified schema-based instruction, which of course builds in that generalization in terms of teaching them the problem structures.
Right, of course. Wow, that's really fantastic. Cool.
We're excited.
So did this surprise you? Was this consistent with literature? Was it something about this that surprised you?
So it didn't necessarily surprise me. In previous studies, we had seen that schema-based instruction really did help the students solve the problems accurately. They increased in their problem-solving abilities. This was the first attempt that our research group made at trying to measure their use of mathematical practices. And we knew that those mathematical practices, specifically communication and reasoning, were areas that were very difficult for students with autism, and particularly the 4 students we worked with. It was the main concern that the general education teachers had in terms of those students' mathematical performance. So I was hopeful, but also not confident that it would work as well as it did. I was surprised at how well they generalized, because that is not something we had seen in the past. And they generalized between those problem types. And we actually included a generalization probe, which was the same types of word problems, but it contained extraneous information. And 3 of the 4 of them were able to also generalize to those word problems that had extraneous information. I did not explicitly teach them how to identify what was relevant and what was not, but they generalized. They were able to do it on their own without any additional instruction outside of that MSBI.
Cool. And this is a schema-based instruction has been studied a number of times with kids with reading or math problems, disabilities. Have there been many with kids with autism? Is this among the first?
We have been studying it for the past couple of years. So there have been quite a few in the last, I would say 2 or 3 years. We have seen that modified schema-based instruction in particular has been very successful for students with autism.
Okay, cool. That sounds great. And this is research. This is science. Research in science, of course, has their limitations. I'll ask you to highlight one limitation of your study, please.
So I would say the largest limitation for this study for me is the fact that we really don't know which components of this intervention package, really, because that's what it was an intervention package. Which ones were the non-negotiables? Which ones did they really need in order to be successful? Because again, these students were in general education classrooms. So was it the fact that they worked one-on-one with someone and just received that type of intervention? Was it the heuristic itself? Was it the instruction with the heuristic? We saw that just the heuristic with no instruction did nothing because they had it in baseline. Right. But was it just us teaching them what does it mean to communicate? What are different ways you can communicate your reasoning? Or was it really the schema instruction, the identification of the structure of the problem and mapping it into that diagram? So I think for me, that's the largest limitation in terms of how would we really implement this in a classroom. We don't know which pieces we really need and which pieces maybe were not necessary for the students to still be successful.
Cool. Sounds like a couple of next studies all lined up. That's cool. That was great. Thank you so much. I really appreciate this. Again, this article is published in Exceptional Children. It's available online. Sarah, thanks so much.
Thank you very much.